Okay, so we discussed the percentile. So, quartile. Okay, so in quartile, and then how will you find the 5-number summary? The what? 5-number summary.
Arrange in order first.
First is arrange.
Yeah.
And then, okay, it's already arranged.
Find
Then,
median.
find the?
Median.
Okay, what will be the median?
Quartile 2.
Okay. Next.
Then we find the median between the
Again, find the median.
in the minimum and the second quartile.
Okay, so that will be quartile 1. And then,
Minimum between the maximum and
the median between.
the median. Yeah.
And then the answer will be quartile 3. So this quartile 1, quartile 2, quartile 3. My question is 5-number summary.
Minimum outliers.
Okay, so that is minimum and maximum.
Oh.
Next, we discussed also how to find the interquartile. So in interquartile range, what does it mean? Okay, now we are using interquartile range to identify the outliers. Can you please tell me the formula, Hannah, how to find the outliers?
1 QR equals T3 minus QR. No, wait, sorry. To find the outlier.
Outlier.
Yeah, that, no?
So you will multiply 1.5.
By the IQR.
Okay, so interquartile range, and then you will get the plus minus of that answer from quartile 1 and quartile 3. Now, how will you know if this given data is an outlier?
It's greater than, if it's less than the answer for quartile 1 minus 1.5.
Correct.
And if it's higher than the answer for quartile 2 plus 1.5.
Excellent. So that is how you find the outlier. Question?
Yes, yeah.
Sheena's gonna
Yes.
the
Yes, Maria.
August checks.
Multiplied by 1.5.
Why do you multiply? That's the formula that you. That's the formula to find the outlier.
Isn't it minus and
Plus and minus.
IBT.
I thought it's
Quartile 1 plus minus 1.5 IQR.
Why 1.5?
Between that and the squeeze theorem. Basically,
Quartile 1 plus wrong minus 1.5 IQR and quartile 3 plus 1.5 IQR.
Yes, but it was just in multiple.
Yeah, multiply.
Yeah.
Meaning 1.5 times your IQR. What's the answer for your IQR? What's your IQR?
It's 25, right?
Quartile 3 minus quartile 1. Okay,
But
next.
why 1.1?
Whisker, drawing box whisker plus. Colleen, how will you graph the box and whisker?
Lowest value, quarter 1,
Then,
is the median,
quartile 2, median, that's correct.
and then quarter 3, and then
And
highest
then,
value.
okay, now draw a box in all quartile and draw the 2 lines for the minimum and maximum.
Yes.
So next example, Sultan, this is your question. Yesterday, so fractal summary and simple. Quartiles divide the data into 4 equal parts. Deciles divide the data sets into 10 equal parts. And percentile is divide the data sets into 100 equal parts. So this is your question for deciles. Okay, interpreting the percentile. Look at the graph. Will you please read also? Yep.
What score represents the 80th percentile?
Okay, on the board, tell me how will you solve that question. So it says here that you need to identify the 80th percentile. What is y-axis? Okay, very good. So y-axis is percentile. What is the x-axis? Okay, now how are you going to find?
Percentile? So what score represents the 80th
Correct?
percentages? And then we look at the x-axis of the scores.
Okay.
Okay. And since this is cumulative frequency, we can just basically find where.
Okay, draw a line. Show.
Emphasize it.
Here,
And
this point, and down here, this point.
okay,
So it's
now
between 1200 and 1400, this is 1300, so about 1200.
okay. Did you understand?
Yeah.
Question? Clear?
Best I don't understand.
Okay, I will just repeat. Abdu, where can you see the percentile?
Okay, so we're looking for the 80th percentile.
And then?
So we're looking for the 80th percentile. That's up here. Okay. The question is, what score represents the 80th percentile? So this question is literally as easy as finding 80% or the 80th percentile, and then literally drawing a line or like seeing where it meets on the line. Yeah. And then you go down, you see where the score is, because we're looking for what score. So the score is, it's between 1200 and 1300. Okay? So it's like 12, it's about 1250.
When drawing the graph, does it always need to be cumulative frequency?
Because it's a
Okay. So if it is not an Ojav graph, can we still find the percentile for it?
It's better if you will do the percentile so you can easily identify. That's why it's percentage.
Wait,
You can easily identify. You can easily identify the points.
Okay, but then how do we do that graph? Because this is an easy example because it is a cumulative graph, so it's not going to come down. And it's also SAT scores only go into 100, so it's easy for us to use the thingy. But when we have real data, most likely the data will not go up until 100. It will go, let's say, up until 9 or up until 5. How do we do things like that? And how do we do it in a, like, if it's not an Ojive graph?
So you need to do that in object graph so you can easily identify.
So it is always cumulative frequency, no matter what we're trying to do, always cumulative frequency. Okay, how about making it percentile? How can we do that? Do we divide it by 100 and then do like the highest score?
It's always 100.
100%.
100%.
Okay.
Okay, it's always like that.
Like
And
the
as you
scores
can see here, you can easily
See?
1600.
Because you a full score at SAT is 1600.
Then what is the 100 thingy on the?
That's percentile, like 10%, 20%, 100%.
You mean as in like the amount of students?
Like if you get
Is that
1600,
frequency?
that's 100%.
Look,
Okay.
It's overcomplicated.
this is the interpretation we can make from this.
Okay.
This means that approximately 80% of all the students scored about 1200. So, like, if, out of all the students who did the SAT, 80% got 1250
Okay.
or less.
Okay.
So it doesn't mean. It doesn't
So
mean
the
that,
percentile can also be known as like frequency in a way?
Frequency is the number of students who answer
I'm sorry, guys.
SAT. Okay, but the percentage is like a mock test. What is your level among all the students who took the mock test? So you're 99%, 98%, 80%. So all the students who took the test. Okay, so that is the percentage. Now, how many students? So how many students are there is the x-axis. So you cannot say
But isn't the
that
x-axis
frequency
score?
Sorry, the x-axis, the score. You cannot say that the frequency is the
Percentile.
percentile.
So there is no frequency in this.
No frequency. No frequency. Because this is just only the percentile.
Okay.
And then the other one is the score.
Miss, does OJAI always have frequency or no?
Did you understand?
OJAI? You can solve the percentage based on the frequency.
Yeah, it's just
Okay, say that the score area, like what they
it's just
say like
Number of students.
yeah, because you're plotting how many students you have.
Students who
I'm not saying how many students got the job.
Yes.
I'm saying
The score of
how
the
many
students.
students got the
At 80th percentile. 80th
So that means it's
شوف percentile why
and then after that,
لما توصل للأول تنزل لتحت
after it's higher than 2050, you're in the 20% of students. So you're top 20%.
That percentage is what
The question's wrong.
Wait, let me see if I understand. So the frequency is the area under the graph.
Well, any question?
For the 80th percentile thing, it's okay.
Yes or no?
So the frequency is the area below the graph. That is what we can see, like, because the interpretation says that this means that approximately 80% of the students had an ACT score of 125, 1,025. So how can we say that? I don't get it.
How can you say it? Because it's already answered. It's already given there. Now, the one that you're taking is what if you will collect all the data,
Yes.
gather all the data,
Yes.
and then do that.
Yes.
So, I cannot write all the values unless you have all the data. Once that you collect all the data, return to the previous example. So in our previous example, you will get the frequency, you will get the X scores, you will get the cumulative, what are the other, relative frequency, and so on and so forth. Once that you're done with all of that, do the cumulative, do the OJAI. And then that's the time that you can identify. But here, it's already given. It's already, the data is already gathered.
Okay.
Okay? Any other question? Don't worry, we will do that in mock test.
What
Then what?
Miss,
I will give you mock test.
Why?
You will not answer the mock test. I will give you the score. Okay? Or if you want the grades, I will give you the grades. Then identify how many students passed and how many students failed. Or in terms if these questions, I will write this question, what the score represents at 80th percentile who took the statistic test. For example. Question, dun ba?
yeah, Miss, does percentile mean
Percentage. Okay, next. So to find the percentile that corresponding to a specific data entry X, use the formula of number data entry less than X over total number of data entries times 100 because we are talking about the percentage. So example from number 2, for the data example 2, find the percentile that corresponds to 34,000. Will you please look at example number? So let us use the example number 2, 3. Try it yourself too. Okay, so this is example. Ibrahim, will you please read? Ibrahim?
The tuition cost of
and thousands of dollars for 25 liberal arts college are listed. Use technology to find the first, second, and third quartile. What do you observe?
Okay, so in this type of question, the first thing that you will do here is order, and then to find the quartile 2, and then get the median, quartile 1, from quartile 2, from minimum to quartile 2, sorry, correct, quartile 2, then find the median, and then quartile 2 to maximum, find the median, okay? But the question here in example number 6 is, you need to find the percentile do they have the same data?
No.
Okay, anyway, data okay, so find the percentile of example 2, find that corresponds to $34. So what you will do, this is the given. Then there are how many entries? 8. Where did you get 8?
There are 8 data entries.
Okay, how do you get 8?
Less than 34.
How do you get 8 here?
There's a number of data entries that are less than 34.
Listen, total is 12.
So from here, how do you get?
There are 8 numbers that are below 34.
34.
بس خلاص.
1, 2, 3, 4, 5, 6, 7, 8. Did you understand? Okay, next. And then, the question here is you need to find $24. Okay? So this is 34. Now, 1, 2, 3, 4, 5, 6, 7, 8.
Wait, so we start
So
counting
there
from
are 8
33.
entries less than 34 and the total number entries is 25. So all of this is equal to 25. You understand? Did you understand? Okay, now, to find the percentile of 34, the number of data entries less than 34, 8 over 25, which is the total, times 100 is equal to 32. What does 32 represents?
52%.
Okay, so this is the 32nd percentile. So, if you will interpret the tuition cost of $34,000 is greater than 32% of the other tuition costs. Can you please explain the interpretation?
The question is
Explain the interpretation.
I understand
What does it mean?
My only question is why is it creating
Yeah, why is it?
Shouldn't it be higher?
Sorry?
Because 34 is like
Oh, 34
always this 8, right? It's the 8th entry.
34 is not
Okay.
included.
8th entry, so it's above like the other entries that are less than 34.
Correct. That's the reasons why that is greater than. Did you understand?
Abdul,
Okay.
34 is not included in the 32nd percentile. Because it's only talking about the 8 entries less than 34,
Yeah.
not 34 itself.
That's weird. That's why that's greater than.
So all of the data entries that are less than 34 make up 32% of the
Yeah, make up
Yeah.
exactly.
Yeah.
Oh, صح.
Get it?
Good job, Abdul.
That's clear now? Yes? Clear ba?
So angry, look.
So whenever we're looking for
Do you remember the second example? So the score is 1,250 or less. Or less. We need all this the lesson. But here in this type of questions we use the value less than. So that is why tuitions of $30,000 is greater than
The formula is always number of data entries less than X.
Wait, miss. How is it greater? It's a
Lay loves to answer this question, right, Lay?
Yeah.
Especially how many times you answered this type of question.
Yeah, so it's saying that 34, it's saying that the number of data entries less than 34, it makes up 32% of the whole data set. So we don't include 34. That's why 32% of the whole data set is less than 34.
Miss,
Guys, well, it's easier.
Guys, the question literally says less than 34.
Miss. So can we say that 34,000 is 68?
Yes,
60.
if you want to change
do the
the
opposite.
percentage, it's correct. It's also correct.
Okay. So we can subtract and say that it's more than, and then
Yes, you can do that. Okay, any type of interpretation is fine, but make sure the data is correct. Okay, the last example for today is standard score. What?
Oh, this is more. That was in the test.
Will you please read for me?
What
Standard score.
definition.
Definition. What is definition?
The standard score or Z
This
score represents the number of standard deviation of value x lies from the mean mu. Find the Z score.
I'm so sorry. Don't be. Yes.
To find the Z score of a value, use the formula Z is equal to value minus mean over the standard deviation, which is equal to x minus mu over sigma.
Oh, where's standard deviations? Now, what do you mean by standard score? What is this score?
Number of standard deviations of value x lies from the mean.
Look at this one. Look at this.
Miss, isn't this
This is
like
the score.
Ah.
Okay? This is usual score from -2 to +2. This is unusual score, meaning not false in this given. And then this is very unusual score that the answer is -3 to infinity and +3
So
to
it's just how far away a value is
Yes.
from the mean.
Yes, that's correct. Yes?
isn't this like used in Chevy Chev's formula or something similar to find
Chebyshev formula is 1 minus 1 over k to the power of 2.
yeah, k is like the number of steps we're going, right? Away from the standard deviation.
Not away from the standard deviation. Same as the your report. What's your report?
Shapes of
Bell distribution.
Yeah.
Shape distribution. Shape distribution. Okay, so let's have an example. Please, since you're already studying. So will you please read and analyze?
the mean speed of vehicles on stretch of highway is 56 miles per hour, standard deviation of 4 miles per hour. You can measure the speeds of 3 cars traveling along the stretch of highway at 62, 57, and 56 miles per hour. Find a z-score that corresponds to each speed and assume the distribution of the speeds is approximately bell-shaped.
Okay, so when we talk about approximately bell shape, so that is in normal distributions. So can you please tell me all the given?
The speeds of 3 cars.
The speed person.
62 miles per hour, 47, and
Okay, so this is 62 miles per hour.
47 miles.
and 47
That is
per
3 cars traveling, and then 42 miles per hour
the second.
and
56.
56 miles per hour. So you have 3 cars, therefore you have 3
Three values.
score.
And you have the mean
And we
speed.
also,
And you have mean. What's the mean?
56.
miles.
Okay, so you have the mean of 56 miles and
And
another
the distribution is
Deviation
okay, so you have standard deviations of
4 miles per hour.
Now, z-score corresponds to speeds calculated below. So if x is equals to 62, z is equals to 62 minus mean over standard deviation. If x is equals to 47, 47 minus mean over standard deviation. And if x is equals to 56, 56 minus over standard
Wait,
deviation.
Lisa, I have a last question.
Now,
What does these values mean? What do these values
let me
Minus
what's the formula? And you have only one mean. What's the formula? Z score is equals to x minus mu over standard deviation. And since you have three cars traveling, 1, 2, 3, and you have only one mean, which is 56 miles, and one standard deviation, which is 44 miles. 4 miles. Okay? That's why you will compute 1, 2, 3. Now, my question is, what does it mean? What is the answer for Z score 1, Z score 2, and Z score 3? That's what it says. Sorry?
So for positive,
No, it's the
How far away it is from zero?
From 0, that's correct.
Zero is the most usual.
Now, use one. And that use one is
Further
negative.
away, so
Okay, will you please read the interpretation, Sultan?
from the z-score, you can conclude that a speed of 62 miles per hour is 1.5 standard deviations above the mean. A speed of 47 miles per hour is 2.25 standard deviations below the mean. And the speed of 56 miles per hour is equal to the mean. The car traveling 47 miles per hour is said to be traveling unusually low because its speed corresponds to a z-score of negative 2.25.
Okay, now explain.
Explain.
What do you mean by that?
So you have the mean, and it's like the data that are given, for example, 47 miles or 56 miles. You get how much it deviates from the mean, and that is like 1.5 times or 2.25 times.
And then, what do you mean by 2.25?
It is like how far away the data is from the mean.
We have a reference.
how many
What's the
standard
reference?
deviations is it?
Okay, so your reference is 0. If that is positive, negative 2, what's that?
It's two
It's
standard
use 1.
deviations.
Okay, and then that is unused 1 if that is
You need to go back to
negative.
the.
It's negative 2. Negative 2 to positive 2, that is used 1. And it will become unused 1 if that is negative 2 to 3 and negative 3 and 2 to 3. And that is very unused 1 if that is negative 3 negative infinity and 3 to infinity.
So
So
these
it's always between 8 to 0. The one that we did is usually.
There is a used 1. What is used 1 here?
the 0 and then 1.5.
And 1.5 and 0. But unused 1 is negative 2.
Okay, so these
Because that is outside the number.
so these values, they are fixed. They are like continuous in the sense of like every time that I use this, I'm not gonna get like very different values from 3, 2, 1. Okay.
Any other questions?
Wait, can we see the
Miss,
thing?
can you go back to the scale? Just remember the negative 2.
Is usual or unusual?
Use 1. That is inside the range.
So the negative 2.35 is unusual because it's more than negative 2.
Yes, the range of that is.
So anything higher than negative 2 or 2.
2 is included.
Higher
2
than
is included with unusual.
higher than 2.
Yes. Okay. Another example so you can easily understand this type of question. So look at this example. I will not solve this because you already know how to plug that in your formula, but let us analyze the answer. So look at the answer. You want me to do this step by step? Okay. So the table shows that the mean heights and standard deviations for the populations of men and the population of women. Compare the z-score for 6-foot tall man and 6-foot tall woman. Assume the distributions of the heights are approximately bell-shaped. So this is for the height of the men and the height of the woman. You have mean, different mean, and you have standard deviations, you have different standard deviations. Okay? So solve for the man. Z is equals to x minus mu over standard deviation. Sorry?
What's the
7.
Where did you get?
6 feet.
Okay. Note that 6 feet is 7
Okay? So this is 6 feet minus 69.9 over 3 is equals to 0.7. And this, the z-score for woman is 3. How are you going to analyze? Or how are you going? Because I will give you the value and then you need to interpret it. How will you interpret watch? Because a while ago you want to answer.
Okay. Wait, do you want to interpret it or read the interpretation?
Read the interpretation and then
Explain.
explain the interpretation.
So the z-score for the 6 foot tall man is within one standard deviation of the mean of 70 inches or so. This is among the typical height for a man. The z-score for the 6 foot tall woman is about 3 standard deviations from this mean, 64.3. Is unusual height for women. So the mean for men is 69.9 inches. So whenever you have a z-score of, for example, 0.7 in this case, or 1, it's not that different from the mean, so it's not that unusual. So it's within the normal range for men. But for women, the typical height is 64.3 inches. 64.3 inches.
That's the woman's height.
No, no.
Woman, the mean height. So whenever you have a woman with 72 inches, the standard deviation is going to be approximately 3, which is very unusual for women. It's not close to the typical height.
Okay, did you understand?
Yeah.
Is it true?
Yes. Facts.
Don't look at me. Because this shows that it's true. Right? So more the common in this word is man is taller than woman. It's common. Do you want an example, Lane? Do you want to start? Okay.
Miss.
Any question?
Is mu and what's the other one? Variance given always? So we don't have to find it. It's given.
Standard deviation.
Sometimes I will give you this score and then you need to find the others. But common way of solving is yes.
Does this only work for population, or can we also use X bar?
X bar with the sample.
Yeah. So we can. So the formula
But still the same.
for that is X minus X bar over. Okay, so we can.
Okay, class work.